Yeah, good evening. I think in the last video, just we are discussing about mm, stack concept. In the stack, we have seen very clearly how we can able to work with the stack, creation of stack data structure, and what are the various operations that we can able to perform on stack data structure also. We have seen very clearly with the help of examples. Then what is mean by infix expression, how we can able to represent that infix, and what is mean by prefix expression, how to represent that prefix, and even postfix expression, and even examples also we have seen. So how we can convert one type of expression into another type of expression also we have seen, like infix to postfix conversion, what are the theoretical steps, and how we can able to convert with the help of program, and infix to prefix conversion with the help of example program we have seen. Now, so another application of stack is nothing but evaluation, sir. Evaluation of expression. Sir, here we are going to see evaluation. Okay, evaluation of a postfix expression. Because once if you see how to evaluate a postfix, then evaluating prefix will become very easy, right? That's why we will see only one thing, which is nothing but evaluation of postfix. Sir, how to evaluate? For this also, we have certain steps are there, sir. Okay, we have to follow those steps. See, for example, if you have some expression is there, consider I have an expression is there. Sir, here we need to do evaluation, right? So that's why what we are going to take is the expression in the form of numerical values. I'm going to take 1 plus 2. This expression I want to evaluate. Sir, what is the postfix form for this? Sir, is it 1 2 plus or right? Yes, this is nothing but the postfix expression. We have to evaluate this postfix now. Sir, how to do that? Very simple, sir. Here we have to do, okay, we have to do, first we have to scan the data from left to right. What is the first data that we encountered? One, right? So is it an operator or operand? It is an operand. Then push it into the stack. Sir, completed. Next, scan the next data. What is the data? 2. Is it an operand or operator? Operand. So push it into the stack. Sir, next we got 1, sir. We got a plus. Is it operator or operand? It is nothing but operator. Whenever we are getting operator, try to pop one item from the stack, sir, which is nothing but, sir, 2. Try to pop one item from the stack. Then try to use this operator and try to pop one more item from the stack. Whatever result that we got, try to push it into the stack. Now your new stack will become 3. This is not your stack now. Sir, like this we have, I mean, I'm taking just element example I'm taking. Sir, now is the scanning of the data completed? Yes. Then what will happen? The element which is available in the stack, okay, is nothing but the your result. Suppose consider for example sake, I'm taking one more expression like 1 plus 2 into 3 is there. Okay, like 1 plus 2 into 3 is there. Sir, already we covered in the yesterday's session how we can able to represent this. What is the postfix format for this? Sir, it is nothing but 1 2 3 star and then plus we are going to get. Sir, first we have to take a stack. So first we have to scan the data. In the previous, like infix to postfix or infix to prefix conversion, so while scanning the data, first we are going to scan, and whenever we are getting operator, those operators we are pushing into the stack. But here, whenever we are scanning, if we are getting operands, okay, we have to push operands into the stack. Sir, the first one which we have is 1, right? That we are going to push it into the stack. Then what is the next element, sir? 2. It is also operand, right? Try to push it into the stack. Next one is also operand, right? So push it into the stack. Sir, perfectly I push it. What is the next element that I got? Star. Sir, it is an operator, right? we have to pop 2 items from the stack. One is nothing but 3 and apply the operator. One more element is nothing but 2. Whatever result that we are getting, again we have to push it into the stack, sir. Sir, is the scanning completed? No, still we have one more operator is there. So what is that operator? Plus. Now again we have to do 2 more pop operations. So 6 we are going to pop and 1 we are going to pop. Whatever result that we got, try to push it into the stack. Now is the scanning of the data completed? Yes. Now the element which is having which is available or which is existed in the stack is nothing but our result. Like this we can evaluate postfix expression. Sir, everyone please confirm, is the evaluation of a postfix expression, is it clear for you people, friends? Please confirm.
Yes, sir.
It's a very simple step, sir. Nothing is there
Clear,
here. Is it clear?
Clear, sir.
Right. Right. Sir, now what I'm going to do is I will write a program for this purpose. Sir, assume a precedence is required. Okay, precedence is required. Infix to postfix conversion is required. This replace function is not required, I think so. We are not converting into prefix. Even if you take prefix conversion also, same thing, right? Okay, let it be. Evaluation of prefix we will write. Yes, program is as it is available. Now you can see. Sir, first step is what? We have to write a separate function. The name of the function is nothing but postfix underscore evaluation, where it is going to take an expression. It is going to take an expression and we are going to create a stack with empty elements and we are going to get the tokens. What is the tokens here? That expression is there, right? That I am converting into in the form of a list. Sir, after this, for each token, okay, for each token, okay, or for each I value present in the tokens, Sir, if the value of I is equal to plus, that means operator, then what we have to do? You need to get the first number which is there in the stack and we need to get the second number which is available in the stack. Then you need to calculate the result. That result we have to append to the stack n1 plus n2, like this I'm taking. Sir, if your I value is equal to, suppose if your I value, better to write elif, because last video you have seen some problems we got. If it is minus, then same operation, n1 will become s dot pop and n2 will become s dot pop and try to append, so n1 minus n2. Elif, if the value of I is equal to star, if the value of I is equal to star, n1 will become s dot pop and n2 will become s dot pop. Okay, s dot pop and s dot append of, we have to put n1 into n2. Elif, if the value of I is equal to slash, then what we are going to do? Your n1 will become s dot pop and your n2 will become s dot pop. And what is the next operation? We have to append this into n1 by n2. We have to calculate and put it into the stack. Sir, other than this, if you are encountering any symbol, try to directly append that value, sir. Okay, try to append directly that value, whatever item that we have, because if it is not operator, definitely it must be an operand, right? That we are going to push. At the end of this function, okay, after completion of this total for loop, at the end, what we are going to do? We will return the element which is available at the top, which is nothing but a pop. That's all. This is nothing but the result what we are going to get. Sir, now we have to check really whether we are getting these values or not. We need to evaluate. Sir, I'm going to evaluate. What is the function name that we have taken? Postfix evaluation. But you need to give the expression in the postfix format, right? Sir, I don't know expression about postfix. I have an expression in infix. I will call this function. So I will pass the expression in the form of infix, like 1 plus 2. So first it will convert it into postfix, and that postfix expression will be given as an input to postfix evaluation, and later it will be evaluated. Sir, what is the output that we are getting? 3. Expected output is 3. Let me cross check whether we are getting 3 or not. So py space I am giving test.py. So you can see 2 1 we are getting. Sir, is the result is correct? No, because whenever we are getting directly we are appending. That's why it is taking in the form of string, something like that. Try to typecast into integer. Now cross check. 1 second. Sorry, sir. It it is Python, right? Now, sir, is it coming or not? Yes. And we have done one more exercise, like a 2 into 3. What is the output that we are expecting? 7, right? Let me cross check. Yes. This is the way, sir, how to convert your infix expression into postfix notation. I think you people got very clear clarity about this. Sir, can you please confirm? Do you have any doubts up to this, friends? I request everyone to please confirm. Any doubts?
No, sir.
No, sir.
Right. This is nothing but evaluation of postfix what we have. Next, sir, we have seen evaluation of postfix. Is evaluation of prefix is easy? Yes. Evaluation of prefix is also very easy. But what we have to do? First, you need to convert it into prefix. You need to convert it into prefix. Okay, and then you have to pass that. I think better it is not required. Again, one more process we have to write here, right? Whatever expression that we are getting, that will be in the form of a prefix. Again, we have to convert it into postfix. It is a headache process. No need to do that. Simply we can able to ignore. Okay. So this is nothing but what we have about stack data structure, sir. And even we have seen what are the applications that are implemented by using stack data structure. I explained in the very beginning itself. There are so many applications are there. Even when compared with the queue, stack is nothing but the very commonly used data structure which is existed. I think you people got a very clear idea about this one, sir. Sir, any doubts in this stack data structure? With this, the total story of stack got completed. Any doubts, friends?
No, sir.
Yes, I request everyone to please confirm. Any doubts?
No, sir. Clear. Everything is clear.
Right. One second. So with this stack data structure got completed. Now we need to see how we can implement the queue data structure, sir. Okay. Sir, just give me 2 minutes of time. I will be back. Please wait. Right. So let us go for the implementation of a queue, sir. I will take a separate document for this. There I will store this complete queue. Okay. You will get this stack data structure and queue data structure as a separate file, sir. Okay. There you can refer this stack and queue. Right. Sir, coming to this queue, you know very well the introduction, queue data structure. Yes, can you please tell me queue is going to follow which technique? Can you please confirm? Anyone?
First in, first
Queue
out.
is,
First in, first out.
yes. So here the queue is going to follow. So first in, first out, first in, first out. That means the objects which we are going to insert first are the objects which we are going to remove first or access first. And internally, this queue is going to maintain two variables. One is nothing but front, another one is nothing but rear. Here front is always used to, front is always used to accessing the item, or for deletion operation we are going to use which variables are front. And if you take a rear, so rear is always at ending, which is used to perform insert operation. Like this we have, sir, this is nothing but what we are calling it as a queue. Queue means what? First in, first out. If you want to see diagrammatically how this queue is going to represented, sir, in majority of the systems you have seen, right, a queue will be always represented in this style, the person who is going to stand in the queue. Okay, so always the entrance for the queue is in this direction and the movement of the queue is from this direction. The person will come here and the person is go from here. This end is called as what, sir? We are calling it as a rear end, where we are going to perform always insertion operation. Some people are going to use the word called NQ also. Okay, and this one is called as a front variable, where we are going to perform always which operation? Delete operation. We are going to perform delete operation here. Okay, sir, this operation is called as what? Technically there is one more name is there called DQ. Okay, so we can insert the objects from one side and we can delete the object from another side. This is nothing but the technique which is followed in queue data structure, especially in all the languages. Okay, of course here the elements are going to come. This is nothing but technically what is meant by queue. Can you please confirm, is this concept of this queue, is it clear for you people?
Yes.
Yes, sir.
Yes, sir.
Right. Next, sir, coming to the common operations. Okay, so operations on queue. Sir, what are the common operations that we are going to perform on queue? So the following are the very common operations, so that can be performed on queue. Sir, what are the operations? The first operation is nothing but we are calling it as a NQ or insert operation. The second one is nothing but DQ, sir, which is called as delete operation. The next one is nothing but, sir, you can get okay, front element. You can get a front element, or get a front object and get a rear object, because we have two pointers are there, right? One pointer is always pointing at the beginning, other pointer is always pointing at the ending. So we can get these, but in the stack we don't have this facility, because in the stack we can able to get only one item, sir, that is nothing but which is available at the top. Okay, we can able to get only one element from the stack, but here in the queue you can do two operations, that is nothing but getting the data from the beginning or getting the data from ending. Both possibilities are there. Next, what is the next operation? As usual, you can find size of the queue and we can ask for is empty method, whether your queue is empty or not, we can check. And even I think we can able to perform display operation or traversing operation. These are the very frequent operations that we can perform on the queue, sir. Okay. Anyway, how we can able to do all these things we will discuss. And let us see, sir, applications of queue. There are so many applications are there on queue, like whatever we discussed in the stack. The first application, sir, wherever single resource, okay, single resource and multiple consumers are there, they are highly recommended to implement queue. Best example, sir, ticket reservation. Only one person is going to issue the tickets, okay, but multiple persons are going to get that ticket. What will happen? These multiple persons have to arranged in a queue so that the resource person is going to give the tickets one by one. So whenever these kind of things are required, compulsory we have to go for this queue data structure, sir. Even in the operating system, see, we are going to use different applications, right? So if I'm giving some application or if I am executing some 2 to 3 applications, so how the priorities are going to be given? The application which you opened first is going to be loaded first, like that we have. Sir, best example, so printing queue, you can see, suppose I have a printer is there, continuously 10 different documents I have printed, sir. What will happen? All these data, I mean all these status will be available in the printer queue or not? Yes. So what will happen? It is going to process one by one. After printing the first document, it will go for second document. After printing second document, it will go for third document. Like this we are going to get. So this is nothing but what we have. Next, sir, the next one here, even in the computer networks also, we are going to use this queue, sir. Okay. So even in the computer networks also, we are going to use this queue very frequently. So these are nothing but various application areas where we can use queue. There are so many applications are there. Okay. So I think you can able to imagine. Yeah, scheduling algorithms, correct. That's what will come under operating system. Sir, can you please confirm, is the concept of this one, is it clear for you people?
Yes, sir.
Yes, sir.
Right. Sir, now we are going to see the implementation of queue. Sir, queue implementations in Python. Sir, how you can implement these queues in Python? Sir, we have totally 4 options are there. Let us discuss all these ways, sir. The first way is nothing but by using list also we can able to implement. Second one is nothing but we have collection interface is there. I mean collections module is there. In that there is one special function is there called DQ. I think in the stack also we used this. Same thing we can implement here. And even, sir, so there is a one special interface of one special module is there with name queue. In that there is a queue class. Like this also we can implement. Even we can go for our own implementation. Okay. So our own implementations in the sense implementation of queue by using list concept. And the next one, implementation of queue by using linked list. So these are the 5 ways are there how we can implement this queue, sir. First we will see by using list how we can able to do. Sir, very simple. Queue is going to follow the same structure, right? Okay. Here we are going to use append pop operation. Like this we can able to get the data. So directly I'm going to explain the program. Have a look once. Sir, assume this is nothing but my queue, what I'm going to take. My queue is initially empty. Sir, how to check whether it is empty or not? Sir, can I say length of queue is equal to 0? Sir, if it is returning true, can I say is my list is empty, my queue is empty? Yes. Sir, if I'm getting the output as a false, we can say the list is not empty. How to add the object in the queue? Just I'm going to use append operation, because I told very clearly append operation is going to be performed at the ending. Insert operation is going to be performed always at the ending. That's why better to go for which function? Append function. Sir, I'm going to append 10, I'm going to append 20, I'm going to append 30. Now, sir, can I say is my list is empty? No, it is not empty. We will get false. How to display the elements? If you want, you can print the queue. Sir, what output we are going to get? A 10, 20, 30. Now you can able to say we are going to get a 10, 20, 30. Sir, which item is inserted first? That I want. Sir, or else I need to get the element available at front, sir. The element which is available at front. Similarly, I want to get the element available at rear. The element which is available at the front, ready to delete or ready to access, is nothing but 10. The element which is available at rear is 30. How you can get front? Can I take q of 0? How to get rear? Can I take q of -1? So we are going to get name A is not defined. Sorry, it is q. Now you can see the output what we are getting is 10 and 30. Okay, 10 and 30. Like this we are getting. This is nothing but how to get, sir. Sir, next one, please take a bit very special care. I'm going to take pop operation. Sir, I want to remove an element, but which element we have to remove? The element which is available at the first location. Can I take pop of -1? If you take pop of -1, it will remove last element, but I want to remove first element. Can I take pop of 0? Now if you print q, so 10 won't be there. We are going to get 20 and 30. If you want, you can see 20 and 30. The deleted element is nothing but a 10, sir. Now, if I want to delete one more time, sir, don't take pop of 1. You have to take pop of 0 only. That 0th element also will be gone. Now we are going to get 30. Sir, this is the way how we can implement this queue data structure by using our internal list concept. Here we used only two operations: insertion at the ending, deletion from the beginning. So by applying these two, we got our solution. Can you please confirm? Is the concept is clear for everyone, sir?
Yes, sir, clear.
Yes, I request everyone to please confirm. Is the concept is clear?
Yes, sir.
No doubts, right?
Yes.
Right. Next, we have collections DQ is there. By using this also, we can able to get the implementation of queue. Sir, how to do that? Very simple. We have to import from the collections module. From collections, we are going to import DQ. Sir, then I'm going to create a DQ. DQ I'm going to create. Then, sir, how you can able to add the objects? Same like a list, how we have done, same like that we are going to cover. Okay. Let us see how we can implement one by one. Sir, please wait 1 second. 1 second. Yeah, right, sir. Let us see how we can able to work with this. Sir, we have very few common operations are there. Let me apply all these again. Sir, I am going to check whether the length of a queue is it equal to 0 or not. Let us see what output we are going to get. I got a true because the queue is not empty. Then I am going to take q dot append of 311 and I am going to take a q dot append of 322. Now I am taking q dot append of 333. Sir, is the data is going to be appended or not? So then your list will become not empty. We will get false. Sir, I want to see the elements available in the queue. Let us see what we are going to get. So we are getting DQ with elements 311, 322, and then 333. Like this we are going to get. Sir, now my requirement is I want to get the element which is available in the beginning. Sir, can I take a q of 0? Let us see what will happen. It is going to return 311. Sir, can I take a q of -1? Sir, same thing like how we applied by using list, same thing. We got a 311. Sir, even we have we can delete the elements. Sir, how we can delete? Sir, can I perform pop operation? Let me check how we are going to do that. Sir, if I remove one object, so like something like print of, so q dot pop of 0. Now see what will happen. Sir, the object, have you observed? Dq dot pop takes no arguments. So if we are not giving any value, sir, which object it is removing? It is removing last object, but that is not our case, right? We have to remove first object. For that, we have one special function is there called pop left. Now you can see which item got removed, sir. 311 got removed. Now in our queue, we have 322 and then 333 is there. Sir, which item is removed? 311. Like that we can able to take. Like that we can able to take. Sir, now I am trying to find out length of the queue. How many elements are there, sir? We have only 2 elements are there. Okay, we have only 2 elements are there. Like this, we can perform various operations on DQ, I mean Q, by using this DQ methodology, sir. So it is available in the form of a predefined collections module. From that we have to import and then we need to use. Can you please confirm, is this concept of creating object for DQ and working with this Q, is this concept is clear for you people, friends? Please confirm everyone.
Sir.
Sir, clear.
Clear?
Yes, sir.
Right. Now we have a queue data structure is there. There is a separate module is there with name queue. In that also we can able to work. Sir, let us see how you can do that. So from queue, I'm going to import a queue. So sorry, first module name, and then this one is nothing but a capital Q. Sir, I'm creating a queue, but here compulsory you need to provide what is the maximum capacity of the queue. How many elements it is going to hold, you need to provide in advance, sir. Now you can see we got a queue object is there. Okay, so we have a queue object is there. So now I want to perform insert operation. How we can able to do that? Very simple, sir. Let me check first size of the queue. Sir, can I get a size function? How many elements are there? I think 0 elements are there in queue dot size. Sir, somewhere yesterday we have seen the functions, right? One second. Yeah. We have methods are there. Second, I'm taking those methods. Yeah, we have the methods like queue size is there, which is going to return how many elements are there in the queue. You can see we have 0 elements are there in the queue. Sir, next what I'm going to do is, sir, I'm going to perform insert operation. How to do that? So we have one special function is there to insert the elements. What is that function is nothing but, do you know NQ? NQ is nothing but a special function which is available in Q to perform insert operation, or we can do by using append also. 1 second. Yeah, so we can use a put function. So just I'm trying to insert let us take a 10, okay, and let us take a 20, and let us take a 30. So capacity is 40. Capacity is nothing but 4 elements. Sir, is it possible to display those elements? No, we are going to get in the form of a Q object only. Now let me call size, sir. How many elements are there here? I think we have 4 elements are there. Now we will see some more operations. Sir, Q dot, is my queue is empty or not? Sir, we are going to get a false because my queue is having some content. But if I execute this method in the beginning, we will get a true because the queue is not added with any elements. Like that, we can check whether queue is empty or not, and we can check the size also. Sir, now next we can call one more function like q dot get. So let us see which element it is going to return, sir. Okay, it is going to remove and return one item from the queue. So since it is following queue data structure, we are going to get 10. Sir, it is not going to hold the objects. I mean, we can't able to see all the objects. It is used in multi-threading environment, sir. Okay, we are going to fix the capacity of the queue and we are going to push the items. I mean, we are going to insert the items and we will perform delete operation. Only for putting and getting, especially in the multi-threading domain, we are going to use these things. This is nothing but what we have inbuilt queue concept, what we required. Okay, I think you people understood very clearly how to use these predefined ways for creating queue objects. Please confirm, is these concepts are clear for you people, sir?
Yes, sir.
Clear.
Clear, right? So now the next one, what we have, we need to implement implementation of a queue by using list. That means we have to write our own code, sir, for implementing this queue. Let us see how I am going to take. I will take my own class with name Q. Okay. Otherwise, let us take capital Q. It is also there. Let us take a Q like this. I am taking. Better I will take Q like this only. Anyway, local will have highest priority. 1 second, please wait. So class Q I am taking, class Q I am taking, and I am going to define a constructor here. Sir, I am taking self and then capacity. So self dot, I'm creating a queue, sir. Self dot, I'm creating a queue. What name I can give? Sir, I'm going to give QUE. Q is equal to, sir, initially all the values are none. With whatever capacity you are going to give, with the given capacity, I'm going to create a queue with all these elements. Sir, after that, I'm going to assign the capacity. Whatever capacity that you have given, I will take. And initially, the size of this queue is nothing but how many elements I am going to take at the very beginning? 0 number of elements. So once if you create a queue class, you are going to get these attributes. I can say it is nothing but creation of queue. Next, sir, after this, I'm going to implement few functionalities. So what is the function is nothing but is full function I'm going to check. So is full is the function. So what this is full function is going to do, it will return true when your size of a Q is reached to size of the capacity. So if my capacity is 4 and elements also 4 means I can say my Q is full. We can't able to insert the objects. Similarly, is empty function. Sir, is empty function I'm going to take where we are going to get self and return if self dot size. Okay, if self dot size is equal to 0, then we can say that list is empty or not. Yes, we can say that list is empty. Sir, next and after that, okay, next and after that, I'm going to take one more function called get size. Okay, size of the function. I'm going to define the function called size, which is going to return actually how many number of elements are there. Like that, I defined only few basic functionalities. Now let us create a queue, sir. I'm going to create a queue is equal to the name of the queue which I have taken is queue. Now I am going to print what is the Q dot capacity or what is the size of the queue. Sir, initially how many elements are there with us? We don't have any elements. Sir, one required positional. Assume the queue capacity I am giving 4. Now you can see int object is not callable. Size. We have a function is there, at the same time we have attribute is there. That's why what I will do is instead of size I will take count. How many elements are there we can get by using count. That will be good, right? Now you can see, sir, how many elements are there in the queue as of now? 0 elements are there. Now I am asking, is my queue is empty? Okay, is my queue is empty? How you can check, sir? Is empty function is there. What is output that we are getting? Yes, my queue is empty. We are going to get the output saying true. Sir, is my queue is full? So if you call is full function, it is going to return false because it is not full as of now. So these are nothing but only 3 functions that we implemented here. Sir, everyone please confirm, is these 3 functions are clear for you people, sir? Please confirm everyone.
Yes, sir.
Yes, sir.
Clear, right?
Yes, sir.
Right. Sir, next function, we have to perform display operation. Okay, I need to perform display operation. So def, I am calling display function. Since it is a list directly, we can display. Okay, or else I will do like this. Just try to print. Can I print self dot? What is the name that you have given? QUE. So QUE. Like this, I am going to print. So if you call display function, it is going to display all the elements. Of course, initially all the values are assigned with none. Like this, we are going to get. Okay, so like this, we are going to get my queue is initially empty. Now I want to perform insert operation. How we can perform insert operation, sir? As you can see, we have to check whether my queue is full or not. If it is not full, directly we can perform insert operation. So insert operation I am explaining. So def, I am going to call insert function, which is going to take self comma the data what you are trying to insert. First we will check is self dot is full. Suppose if it is full, then simply we are going to return. We are not doing any activity. Otherwise, self dot count is equal to self dot count plus 1. Okay, and we are going to add that item self dot q. Okay, self dot q of self dot size minus 1. Self dot size minus 1 is equal to the data what you are trying to insert. Sir, initially what is the size, sir? We incremented by 1 unit, right? So self dot count. I think better we can increment, we can store the value here and later we can perform increment operation, right? So initially count is equal to 0. So q of 0 we are going to push the data and the count will become count plus 1. Now let us work on this. So q dot, I am calling insert function by passing 10. Now cross check, is the value 10 is inserted, sir? Yes. Now I am trying to insert 20. Sir, is it inserted? Yes. Now I am trying to insert 30. Is it inserted? Yes. Now I am trying to insert 40. Is it inserted? Yes. Now I am trying to add 50. Sir, is it inserted? No, it is not inserted. And we are not displaying any message. If you want, you can print. So Q is full, can't add the data. Like that, we can print the message. So we will get that message and it is going to terminate. Sir, insert operation is clear, but we need to perform delete operation. So before moving to the delete operation, can you please confirm, is the insert operation is clear for you people, sir? Please confirm.
Yes, sir.
Right. Sir, now we have to perform which operation? Delete operation. Let us see how we can do delete operation in the queue. I am going to take the function name as a delete, which is going to take self. And here we are going to check, is self dot is empty. Suppose if you have empty queue is there, we can't delete. We can say queue is empty, and then we are going to return the control. Otherwise, what we are going to do, so the element which is deleted is nothing but some result. I am going to take a self dot q of 0, and at last we have to return the result. But the problem with this implementation is, if you want, you can see after display, I am trying to print, sir, q dot, okay, q dot delete. It is going to delete one object. Sir, is the deleted object, it will return or not? Yes, it is returning 10. But after this, try to perform display operation and see what is happening. Sir, the element is there in the queue. Okay, the element is there in the queue. So this is nothing but the problem what we are going to get. Okay, sir, we have to write code manually because we captured that element and we printed. Now what we are going to do, don't delete directly because the capacity is going to be changed. Here capacity is main important, right? That's why, sir, for each I value in the range of self dot count, okay, self dot count minus 1. So here see how many elements are there in the queue, sir? We have totally 4 elements are there. These are nothing but the 4 elements in the queue, right? So 0th location, first location, second location, third location. We have 10 is there here, 20 is there here, 30 is there here, and 40 is there here. 0th location, first location, second, third. Now we are going to run a loop. So I is equal to starting from 0, count minus 1. What is a count value here? We are going to get, sir, your count value will become, I think 4, right? 4 elements are there. So 0 to 3, that means 0, 1, 2. Okay, 0, 1, 2, 3. Every time we are going to run the loop. Let us see what we are going to do. Sir, we have to move this 20th element to this position. And we have to move 38th element to this position. Sir, we have to move 40th position, 40th element to this. And the last one will become none because next element is none, right? Let us cross check we are getting any exception or not. So self dot, so q is there, right? Q of I will become, so self dot q of I am taking I plus 1. Let me check, is the all elements are going to be copied or not? Let us do that. Sir, you can see 20th element is copied, 30th element is copied, 40th element is copied. Again, this 40 is there. Sir, how we can able to do that? 1 second. After this, sir, can I perform delete operation? Delete operation, self dot count is equal to count minus 1. Automatically, one item got deleted. And please listen carefully. Before this, in the display function, I am going to call, so q dot size. Okay, what are the, how many elements are there? I think 5 elements are there. Here we have given only 4 elements, right? And after this, I am trying to call, so after deletion, I am trying to call size, sir. My expected output is 3. Is 3, 4 and 3 are coming? Yes. but the element is there. That is, there is a problem with the display function. We have to write a display function properly. Sir, how we can write a display function, sir? First, we are going to check if is self dot is empty. Is my queue is empty or not? I am checking. If it is empty, then I am going to display queue is empty. So then return the control. Otherwise, what we have to do? We need to run a loop which is going to execute how many times? Count times for each I value in the range of sir self dot count -1. Okay, self dot count or self dot count -1. Self dot count, I think so. Sir, what we have to do? We are going to display. Items like this. Self dot. So q of I'm going to print I, and after this I'm going to take end is equal to empty. So before this, I think no need to print any other things, sir. After this, coming out from this display function, we are printing empty print. Now cross check is the display function is working properly. Initially we have 10, 20, 30, 40 is there. So later after deletion of 10, so we have last element is there, right? But we will print up to last before element. Sir, can I perform insert operation again? Yes, no problem. If you perform insert operation, so let me take a q dot insert of 60, where that 60 will be added at the ending or not? At the ending or not? Let me cross check. Sir, the 60 got added at the ending. Like this, we can implement. Any doubts, friends, up to this, whatever we cover? Yes, please confirm. Is the concept is clear, friends?
Yes, sir. Sir, here you also inside front and rear.
Sir?
Front and rear, sir. Give the first position as front. Rear.
Yeah, we can implement in that way also. But if you have array concept, we can do like that. But here we are using list concept, right? That's why simply I'm going to create a list with maximum capacity, and I'm using that index concept to run the show.
Yes.
Which pointer is going to do that? Count pointer is going to do that. Sir, please confirm everyone. Is the concept is clear?
Yes, sir.
Yes, sir.
And here the complexity of this one is more, sir. Okay, the complexity of this algorithm is very high. The reason for that is when you are doing delete operation, we need to shift one element. So it is going to take a big O of n. It is going to take big O of n. So here small note here is, so we can reduce, okay, we can reduce time complexity of delete operation by using circular linked list concept or circular list concept. By using that, we can reduce. But of course you can think and you can implement. Nothing is there. So last pointer will be attached to the first pointer. Beyond that, nothing. So this is nothing but what are the three different ways that we have to implement the queue. First one is what? By using list, how we can do. And second one, so from the collection, we have dequeue method is there. And the third one, in the queue, we have queue method is there. And we have to implement by using linked list. Sir, we will see how to implement by using linked list now. Right. Sir, I will give some 2 to 3 minutes break and then we will continue. Okay. So last implementation is there. So I will take a break for 5 minutes and we will continue. Okay. Please go on refresh just 5 minutes. Right. So let's continue, friends. We will see the implementation of a queue data structure by using linked list. I request everyone to please confirm. Sir, am I audible? Shall we continue? Yes, please confirm. I request everyone to please confirm. Am I audible? Right, sir. 1 second. It is not unmuted. Yeah, now I have given the permission.
Yeah, sir.
Yes, sir. Clear, sir.
Right. Sir, the last implementation, we will implement this queue by using linked list concept. Let us see how we can do, sir. Very simple. Sir, here we need to take a linked list, right? And we know very well how to take linked list. We need a separate class called node. And whenever we are creating a node, it is going to have the data field. And here I'm going to assign data field is equal to the data whatever you have given. And the next field is always pointing to the none. I created one node class. We know since we are representing this by using linked list, we need to take the node class. Then I'm taking class myQ. I'm going to implement a class called myQ. What is the first operation? We need to do the construction, right? We need to do the construction. For that, I'm taking init method where it is going to take only one parameter called self. So self dot front is equal to, initially here I'm taking front and rear both pointers because we need to identify the beginning and we need to identify the ending. So beginning, for what purpose we are taking beginning, sir? For performing delete operation or for accessing operation. Why we need to go for last pointer? For insert operation. That's why. So generally we will take a head and a tail, but here since it is a queue, I used two reference variables, front and then rear. Both are pointing to the none. Both are pointing to the none. And what is the size of the queue, sir? The size of the queue is initially 0. Like this we have. Then I will define some function to get a size of the queue. The function name is nothing but a size function, which is going to return how many elements are there. How it is going to return, sir? It is nothing but a count. And I'm going to write isEmpty function. Sir, how to check isEmpty? Is the queue is empty or not? How you can check? So if it is going to return, if your self dot count is equal to 0. If you have 0 elements are there, then we can able to say my queue is nothing but empty. Then I'm going to get the front item, get a front. How to get a front? So get a front function I'm going to write where it is going to return self dot front dot data. Sir, if it is available, it will return. Similarly, sir, I'm going to ask get rare where it is available. So rare element. So get rare I'm taking, which is a pointing self, and I'm going to return self dot rare dot data. Sir, here you can see only few operations I implemented, sir. So how to construct a linked list and how to get size of the linked list, and is the linked list is empty or not, and front data and rear data. Sir, do you know here we are going to create a linked list dynamically. As you can able to see, you can perform any number of insert operation. That's why queue full such a type of concept is not applicable here. And if you are okay with this, I will try to perform the main operations like insertion, deletion, and then display. Can you please confirm, is this concept is clear up to this? Please confirm, friends.
Yes,
Is the concept is clear up to this, whatever I covered?
Clear.
Yes, sir.
Right, sir. Now we have to perform insert operation. So here I'm writing code for insert. We know already in the linked list we have seen, right? Insert where we are going to give some data. What is the first step, sir? we have to create one temporary node. So our current node with the data whatever you have given. Then we are going to check is self dot rare is equal to none. That means the list is empty. If the list is empty, self dot friend will become the temporary node. Okay, self dot friend will become temporary node. Sir, if self dot rare is not empty, then I am taking self dot rare is there, right? Its next field will become temp. Okay, self dot rare is there, right? Its next field will become temp. Sir, otherwise, if these two conditions are satisfied, then I am taking self dot rare is equal to, so the newly created node, and automatically self dot count is equal to self dot count plus 1. Sir, definitely you have to see the diagram, then only you can able to understand. Sir, consider initially I don't have any queue, sir. So immediately, if you don't have any queue, one second. So if you don't have any queue, then what will happen, sir? So my initially, so front pointer is there, right? So here my front pointer, okay, my front pointer is always pointing to none, sir. And even my rear pointer is there, right? It is always pointing to none. Sir, I am inserting the first node. This is the first node, right? And do you know this node will become a temporary node and two fields will be there. Consider the data is 10. Next field is none. Like this we have. Sir, we created a temporary node. Is rare is none? Yes. Then this will become your friend. Okay, this will become your friend. This will become your friend. And friend is equal to temp, else is not executed. And this is also is nothing but what? Rare, sir. And the count will be incremented by 1 unit. This is nothing but my new linked list. I mean my new queue. Sir, I want to perform one more insert operation. We know it will be added here. Sir, this is the new node. Consider next field is none, data is 20. And this node is what, sir? Temporary node or not? Yes. Is self dot rare is equal to none? No. Then self dot rare dot next. So say this is nothing but rare. It's a next field I am attaching to the temporary node. Then what will happen? Come out from the if, and then self dot rare is equal to temp. This will become rare now. That's all right. So count will be automatically incremented. Like if I am adding, if I am creating one more node, so it will be created here, and this node will become temporary node. The data is 30, next field is none. And as you can see, is self dot rare is equal to none? No, rare is available. So rare dot next will become temp. That means this next field is attached to this one. After that, coming out from the if condition, self dot rare will become temp. So this will become rare, sir. Automatically, these reference variables will be gone. Like this, insert operation is going to be performed at the end of the queue. I request everyone to please confirm, is this insert operation, is it clear for you people, friends?
Yes, sir.
Please
Yes, sir.
confirm, is it clear? Right. Sir, we have to write code for display operation. Okay. Let us see. I think we are very familiar with the display function. First, we are going to check whether the queue is empty or not. Okay. So how to check is empty function is there, right? Self dot is empty. If it is true, then we are going to print the message saying, okay, so queue is empty. Okay. And then return the control. Otherwise, what we can able to do? I am taking current node, which is pointing always from self dot friend. So while your current node is not equal to, okay, your current node dot next is not equal to none. You can repeat what we are going to print, sir. Can we print current node dot data and take end is equal to space? Sir, every time your current node will become current node dot next. Like this we will go. At last, we are going to print empty line. Now we will work out on this. Sir, Q is equal to my Q I am taking. So let us apply the basic operations. Q dot, what is the first operation? Size is empty. Okay. So first I will ask size. What output we are going to get, we will see now. You can see 0 we are getting. Now print dot Q dot is empty. Sir, is my Q is empty? Yes, it is going to return true because it is empty. Now I want to call Q dot display function. Okay, so Q dot I am calling display function. Sir, do we have any elements in the Q? No, right? That's why Q is empty. Now try to perform insert operation, sir. How to do that? So Q dot insert of, let me insert 10, let us insert 20, let us insert 30. Now I am going to do display operation. Sir, we got only 10 and 20, that 30 is not added. That means while current dot next is not equal to none, current is initially self dot front. Okay, current dot next is not equal to none. Yes, it is not equal to none. It will print current data. Current will become current dot next. Maybe rare value. Better we will print here. So current node dot data. Let us see what will happen. Is it going to print? I think instead of next, better we can take current node is not equal to. This will be cool. I think so. Let me cross check. Yes, we are getting the items. Now, sir, I will call these two functions. Is my Q is empty? Size is nothing but 3 elements. Is my Q is empty? No, it is not empty. Like this we have. Sir, I think it is very clear for you, right? If you are okay with this, I will perform delete operation. Can you please confirm, is these methods are clear for you people, friends?
Yes, sir.
Yes, sir.
Right, sir. Now we are going to perform the next operation, which is nothing but a delete operation. Let us see how it will be. Sir, I am going to do delete operation. DEF, I am taking delete. The function name is self. Sir, from where we have to delete? From the front, right? I am going to check one if condition. Sir, if self dot front is equal to none, we don't have any elements, then simply we are going to return none. No object is there to delete. Otherwise, if the condition is fail, result is equal to. That means the element which we are going to delete is nothing but self dot front dot data. At last, we have to return that data. Sir, meanwhile, we have to delete that link. Sir, how you can able to do that? Very simple, sir. Self dot front is equal to self dot front dot next. Self dot front dot next. Sir, you are making your front is referencing to the next element. Okay. So in this case, what will happen, sir? In this case, what will happen? This front we are moving to this. By default, this content will be gone. Sir, next time if you perform delete operation, this front will be moved to here and we are going to perform delete operation here. Sir, now again if you are trying to delete, what will happen? This front is going to move to the none, sir. If it is moved to the none, then what is the meaning? We don't have any elements, right? That condition also we have to check. So if after doing this, if your self dot front is by mistake pointing to the none, that means we are having only one element and that element we deleted, then immediately please change a rare pointer also to the none. And after doing all these operations, compulsory self dot count will become self dot count -1. Then only that element will be deleted. Now have a look once. So Q dot I called display function. Now I am going to call print of Q dot. I am going to perform delete operation. Sir, which item it is going to be deleted? Definitely the first item it is going to delete. Okay, this is nothing but how to implement various operations on Q data structure. Can you please confirm, is the implementation of Q by using linked list? Is it clear for you people, sir?
Yes, sir. Clear.
Yes, sir. Clear, sir.
Yes, please confirm everyone. Is the concept is clear up to this whatever I am going to cover? Is it clear?
Yes, sir.
Please confirm, friends.
Yes, sir.
Right. So with this, queue data structure is finished. Of course, here, like Stack, we don't have so many applications. If you want, you can do that, reverse all these things. But for that, we need to depend on another data structure. But the queue we are going to use in tree data structure and graph data structure for evaluating the algorithms. There we will talk about this in detail. Okay. So with this, stack data structure and queue data structure got finished. Please don't leave the meeting. Please wait.